Hi, good morning. Today, my classmate Josue and I are going to be talking about the CO2 and everything involved with it. So we're going to start by its chemistry. As we know, the carbon dioxide is a gas that it is obtained as a result of multiple chemistry and biological processes. This gas is found in low proportion in our atmosphere, exactly 0.04%. The carbon dioxide is constituted by two atoms of oxygen and one atom of carbon. For this reason, its formula is CO2. We can see it right here, it's linear form. This molecule has a linear and a symmetric geometry. Here we have the Lewis structure. Now, talking about some properties, physical and also chemistry properties of the CO2, we have that at the room temperature and atmospheric pressure conditions, CO2 is a colorless and no-smell gas. It can solidify if it is subjected to temperatures under the minus 79 degrees. It can decompose if it is exposed to high temperatures over the 2000 degrees. Its melting point is in the minus 56.6 and 5.2 atm. Also, carbon dioxide has highly solubility in water. Each volume of water dissolves in 0.9 volume of CO2. And finally, it has a density of 1.976 kilograms over meters. We have also the formation of this gas. We have these processes. We have the combustion. We can say that the combustion of fossil and non-fossil materials like gas, petroleum, carbon, and others produce carbon dioxide. Also, we have the fermentation. This process of the fermentation, we have like sugar, for example, that some yeast and bacteria usually produce some acid, alcohol, and CO2. We have the respiration process. This process of animal respiration basically consists in taking oxygen and release carbon dioxide outside. Finally, we have the process of the carbonates and acid reaction. Some salts, acid carbonates, can react with some acids and form carbon dioxide. We have also the Henry law and CO2. Something important that we need to mention is that the amount of carbon dioxide found in a solution determines the pH of the water. This is why when water is acid, it is associated with the amount of CO2 dissolved in this body of water. If there is more CO2 in the water, the pH is going to be lower. This happens because when CO2 becomes aqueous in the water, a small amount converts itself into carbonic acid. The Henry law says that the solubility of a gas in a liquid is directly proportional to partial pressure of the gas over the liquid. According to the Henry law, the CO2 is going to expand until it reaches with the atmosphere. This balance point basically is called a superior limit, also named the ceiling. We know that the pH increases when the carbon dioxide delivered from the water and reach the pH ceiling.
Well, what about the vertical distribution of CO2? At the surface, photosynthesis consumes CO2, so CO2 levels remain relatively low. In addition, organisms that use carbonate in their shells are common near the surface, further reducing the amount of dissolved CO2. In deeper water, CO2 concentration increases as respiration exceeds photosynthesis, and the composition of organic matter adds additional CO2 to the water. As with oxygen, there is often more CO2 at depth because cold bottom water holds more dissolved gases, and high pressures increase solubility. Deep water in the Pacific contains more CO2 than the Atlantic, as the Pacific water is older and has accumulated more CO2 from the respiration of benthic organisms. What about horizontal distribution of CO2? The horizontal distribution in the surface ocean is mainly governed by the temperature-dependent solubility of CO2 on interannual timescales. Warm, low-latitude surface water generally holds less CO2 than cold, high-latitude surface water because of the enhanced solubility at low temperature. Locally and seasonally timescales However, significant deviations from these general patterns may occur due to changes in salinity and processes such as biological activity, upwelling, and temperature variations, and other processes which affect CO2. Deep ocean circulations, whose mass transport in predominantly from the North Atlantic through the Southern Ocean into the Indian and Pacific Ocean, produces horizontal deep water gradients in CO2 and total alkalinity. Finally, we have the impacts of CO2. Main important is the ocean acidification. In recent years, there has been rising concern about the phenomenon of ocean acidification. As described in the processes above, the addition of CO2 to the seawaters lowers the pH of the water. As anthropogenic sources of atmospheric CO2 have increased since the industrial revolutions, the oceans have been absorbing an increasing amount of CO2, and researchers have documented a decline in ocean pH from about 8.2 to 8.1 in the last century. This may not appear to be much of a change, but remember that since pH is on a logarithmic scale, this decline represents a 30% increase in acidity. It should be noted that even at a pH of 8.1, the ocean is not actually acid. The term acidification refers to the fact that the pH is becoming lower. For example, the water is moving towards more acidic conditions. Thank you.